Hi everyone, welcome to thlympic. This is teacher Adnan, and we are going to solve some new questions in our video. Let's start. So this is our first question from category 1 Math Challenge test questions. So if you can stop and read the question. So a student choose a number from a box, and this number have this property. 1 less than half of number is equal to 3 more than 1/3 of same number. So the problem is here. 1 less than half of the number is equal to 3 more than 1/3 of same number. So we need to focus underlined part. There may be more ways, but I have shown 2 ways. One is with equation. If you know how to write equation, maybe it is much simpler. So we need to choose a number x. So 1 less than half of x. This is the first part. And 3 more than 1/3 of x. And they are equal. So to solve this equation, so we need to simplify these fractional parts. So if we multiply by 6, so 6 times x over 2, 3x, 6 times 1, 6, 6 times x over 3, 2x, 6 times 3, 18. So in the next step, we do not have any fraction, and it is simpler than the first one. Just let's solve this equation. So unknowns on one side, the numbers on the other side. So 3x minus 2x is x, 18 plus 6 is 24. So the answer is 24. To check, you can just substitute here and check whether it works or not. The second way, if you don't know how to write this kind of equation, so you can make a big bar. So we need to divide by half. Also, we need to divide into 3 equal parts. So 1, 2. Okay, so there will be 3 parts, 1, 2, and 3. But the problem is when you first divide into just 1/3 and 3 equal parts, you will have something like this. 1 minute, let me change this color too. So in this case, the problem is this part is smaller than these parts. So to make them all equal, so we can divide into 6 equal parts. So if we divide our shape into 6 equal parts, so we can understand much better, because this is half and these are 1/3, right? So according to this, let's check what we need to do. 1 less than half. So if this is half, so the black line is 1 less than half when we consider this red part as 1. The second part is 3 more than 1/3. So this is 1/3, and if we add 3 more, so again we reach the same point because they are equal. Now when you check carefully, this rectangle has the value 3 plus 1, 4 units. So one rectangle has 4 units. So this is 4, 4, 4, 4, 4, 4. So there are 6 parts. 6 times 4, 24. So as you see, we get the same result. One with equation, another without writing any equation. Now the second question is, what is the smallest integer that should be added to 2010 to get a perfect square? So if you are good in calculation, so you can realize that this should be more than 40, because 40 square is 1600. So you may check 41, 42, 43 and try to get which one is the closest. but we can also use some approximation techniques. So here I used 3 different approximations, and the final one is much better than previous 2. In the first one, instead of 2000, instead of 2010, I used 2000 because the 2000 we can separate into 2 parts. One is a perfect square, another is not. And we can approximate 20. 20 is closer to perfect square 16. So if we do this rough approximation, here we got 4, here we got 10, it is 40. So we can roughly say that 40 square is a closer perfect square. But we see that it is not actually that close. So we need to check a bigger number, maybe 41 or 42, so we are not sure. So in the second one, so I have seen this on YouTube many times, to approximate a square root number like 20. So we know that this is more than 16. So this equals the 4, which is closest perfect number, because this is more than 4. So 4 plus something between 0 and 1, because less than 5, right? 5 squared is 25, and 4 squared is 16. So this is between 4 and 5. So it is 4 plus something. So this is a kind of approximation. So this number minus the smaller perfect square divided by that perfect square. So what we get is, here it comes 1 over 4, or 0.25. So 4 plus 0.25, 4.25 times 10 equals 43. When you round it, you get 43. So, and if you check the square of this, it is still smaller than this, but closer than 1,600. So you realize that you need to check other numbers bigger than this. So then you can check 44 and 45. In the final one, I have seen this formula on internet. So to see the closest perfect number to a square root number, so what we do is we choose the closest perfect number. Let's say y is the closest perfect number. So x plus y divided by 2 times root y. This gives a very close approximation to this number. So here, if we get a very close value of root 20, so we can get approximately what is that perfect number. So here, this is 10 again, but for this one, I use the formula above. So this is 20 plus 16 is the closest perfect number, and 2 times root 16. If we simplify this, this is 36 divided by 8, and when you multiply by 10, we get 45. So we can say that the 45 square is a close number to this one. Actually, when you take the square of 45, we get 2025, which is very close to this number, and it gives us the answer we need. So to see how much number we need, so 2025 minus 2010, we get 15. So in our third question, we have summation of continuous fractions. So here we see how many, so around 90 fractions, approximately, or 20 fractions. How many? So we have lots of fractions. So it will be not possible to calculate all. So it will be very tough. We need to find an easy way. So what you can do is, since there is multiplication here, so you can think that how can I get something like this? So we know that when we are doing addition or subtraction, so generally we multiply the bottom parts, right? So it means we can separate this into 2 fractions, when they are added or subtracted, you will get something similar. So here I use subtraction. So 1/10 minus 1/12. So if you calculate this, you will get something like this, right? 12 minus 10 over this. So if you simplify, this will be 2/10 times 12. So it's not the same thing, but it looks very similar. So if we apply the same rule for others, so we got 2/10 times 12, 2/12 times 14, so 2 times 19 times 100. So almost same, just we have an extra 2 at the top for each fraction. So when we check this addition, we can remove the brackets. Look at this blue part. So after we remove all the brackets, we see that 1/10 minus 1/12, first bracket, second bracket, and it continues. So we see that, look, these two are canceled and next two will cancel, because so from here, the second one is 1/2, second one is 1/12. The first one in this fraction will be 1/12. Likewise, second one will be 1/14. Second one will get 1/14. So one of them comes positive, the other comes negative. So, and they cancel out. So, and we are ending with just two fractions. So the first one and the last one. See, so it is very easy to calculate this expression. So this expression equals 1/10 minus 1/100. And if you do this subtraction, you get 9/100. So 9/100 equals this whole expression. So, and we realize that the inside bracket is just as this one. So we factor out 2 because 2 was common in all the fractions here. So after you factor out 2, the inside bracket is exactly same as what we need. So if you call this as A, so this will be A. So 2 times A is 2A equals 9/100. From here, A comes 9/200. And our final question from category 4, it's related to logic. So if you do not have any idea, you may find it quite hard. Okay, so here a statement is given as false. So they ask the true values of P and Q. Now first, let's make a true-false table for PQ. See, we made a true-false value. This is the standard form of PQ true-false values. So what we need is negation of P and then negation P or Q. So negation P is just opposite P. If P is true, negation will be false. And if P is false, negation will be true. So this is the negation table, true-false table for P. And negation P or Q. So for OR statement, if one of them is true, the OR will come true. So for example, here, negation P and Q. This is true, so it will be true. If both of them false, the OR statement will give false. If both true or one of them is true, it will be true. Now here we have negation P or Q. The final statement is if P, then negation P or Q. So in this case, in this kind of if statement, the rule is, what is the rule? P or, okay, so this is, if P, then this, okay. This comes false only if P is true, but this part is false. So you say that, so if you do this, I will do this, okay? So if the condition is done, but the result is not done, that case it is wrong. In all other cases, this statement is considered as true. So we check if there is a case where P is true, but the next part is false. So let's go to P. So here, P true, true. And the OR statement is false here. So only this one will come false. See, P is true and OR statement is false, so result will be false. All other cases, the if statement give us true values. So if P is true and this is true, true. If P is false, whatever the next part, it will give us true values. So finally, we have this true-false table for this statement. So the question says, if this statement is false, so we have only one case where this is false, and then let's check the PQ values. Then P is true, Q is false. So this is the part A, or the first option is the answer. And here separately, if P then Q statement is explained, if you do not know. So these are P, these are Q, if P then Q. As you see, this statement is false only if P is true, but Q is false. So thank you very much for today. We have only these 4 questions. See you in next video. See you in the next video.